Okay, I hear the recording in progress, so we'll start sharing the screen. All right, so you should have gotten an email back from me about the quiz. If you did not, let me know right away. And I also sent out a video on the solutions on Saturday, I think it was. Okay, so we're progressing okay. Another quiz this Friday, the 29th, and we're aiming for exam on trig on Friday, the 5th of November. After that, the semester winds down very quickly. We have several holidays coming up also. There's Veterans Day, and we have Thanksgiving, and before you know it, we'll be all done. Okay. In fact, the remaining material after trig is not that much. 5, 2, 3, and 4, that's on exponential and log functions that you've seen before, so that will not be that long, hopefully. And then this is a separate topic. I think it's on analytic geometry. You don't have to write any of that down now, but we'll worry about it when we get to it. Okay. All right, so we're continuing on. I'm actually up to close to finishing 4.6. So I'm about a day ahead, maybe even more than a day. Sneaking a little bit of 4.7, which is on trig identities. But again, the schedule is out of whack because, as was pointed out before, I didn't even include 4.9 in here. But if you imagine cross off where it says buffer day and put 4.9, then that's pretty much where we should be. Okay, so let me do some more problems from 4.6 and then introduce 4.7, but I won't go that far into 4.7. Let me do for you problem number 31 on page 238. This is a little bit bigger. Tangent squared of t is 1/3. And then I was going to do 35. 2 sine 2t, blah, 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 blah. Okay. And then I'll be done with this section. All right, so tangent squared t equals 1/3. Take the square root of both sides. When I do that, I include a plus or minus. So tangent t is plus or minus, well, square root of 1 is 1, so 1 over radical 3. Okay. There's a trick for that. Change tangent to sine over cosine. The trick is for 1 over radical 3, divide top and bottom by 2. Why? Because it works. Okay, so if I set it up this way, well, then I've got sine of t is either plus or minus 1/2, and cosine of t is plus or minus radical 3 over 2. So it's easy to work with 1/2. So I go draw a unit circle. I go halfway up, draw these two angles, pi over 6, 5 pi over 6. And I go halfway down, I get these angles, 7 pi over 6 and 11 pi over 6. Okay, so counting for the plus or minus, right? So I come to the conclusion, I want the y coordinate sign to be either 1/2 here and here, or negative 1/2 here and here. I could also do the cosine, but we're a lot less comfortable with radical 3 over 2, so it's a lot easier to work with 1/2. Okay, and if the sine is 1/2 here, 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 and here, the cosine is indeed plus or minus radical 3 over 2. So here are all the angles: pi over 6, 5 pi over 6, 7 pi over 6, 11 pi over 6. All right, then 35 is a harder problem. A lot of moving parts here. First, they give me a double angle 2t, which I don't like. And then they're mixing up a sine and a tangent in the same problem. So how do I tackle all of that? So first, I don't like the 2t. Let me call theta equal to 2t. Now, in the directions, it says t. T is between 0 and 2 pi. So t is between 0 and 2 pi. I'm going to change this temporarily to theta because I don't want to work with 2t. So theta is 2t, divide both sides by 2. T is theta over 2, or half theta. I'm going to need that a little bit later. All right, so t is between 0 and 2 pi. What I did was multiply each of these by 2. multiply that by 2, multiply that by 2, multiply that by 2. That means 2t, which I'm going to replace the middle now with theta. Theta is between 0 and 4 pi. So when I do my analysis with theta, I have to keep in mind theta can be any angle between 0 and 4 pi. I'm going around a circle twice. Okay, now I'll work this out. So I like that a little bit better. It now says what's 2 sine theta minus radical 2 tangent theta equals 0. Still don't like it too much, but let me change tangent to sine over cosine. 2 sine theta minus radical 2 sine theta over cosine theta equals 0. Multiply both sides by cosine theta. 0 times anything is 0. 2 cosine theta sine theta, or 2 sine theta cosine theta. And here the cosines cancel out. So minus radical 2 sine theta equals 0. Okay, that's a little bit nicer. So now either this one, after factoring out sine of theta, I get this. So either this one is 0 or this one is 0. Sidebar, you have a times b equals 0. Remember from algebra, if you have a times b equaling 0, then either a is 0 or b is 0. So I either make this one 0 or this one 0. So sine theta equals 0, a little bit of algebra. Cosine theta is radical 2 over 2. All right, so I want theta, which can be something between 0 and 4 pi, including 0 and including 4 pi. So what are the values of theta between 0 and 4 pi will make sine of theta equal 0, i.e. y coordinate, right here, y coordinate is 0. Well, 0, pi, 2 pi, 3 pi, and 4 pi. So these 5 angles between 0 and 4 pi will make this a true statement. The sine of that angle will be 0, i.e. y coordinate, here they are, right here the y coordinate is 0. Now, cosine theta is radical 2 over 2. Aha, that tells me reference angle of 45 degrees. That's here and here. Cosine is positive in quadrants 1 and 4. So for theta between 0 and 4 pi, that's going all the way around a circle twice, where will the x coordinate be radical 2 over 2? So I have pi over 4, way over here, which is 7 pi over 4, 8 pi over 4, so 9 pi over 4. And then coming all the way around here, it's almost 4 pi. 4 pi is 16 pi over 4, back up pi over 4, 15 pi over 4. So these are 1, 2, 3, 4, 5, 6, 7, 8, 9 angles for theta. But the original problem wasn't in theta. The original problem was t. Well, how do I get t? Theta divided by 2. So these 9 angles, I just cut them in half, and I got my solutions. So to cut these in half, I just divided by 2. 0, pi over 2, pi, 3 pi over 2. 4 pi over 2 is 2 pi. And then to cut these in half, just change the 4s to 8s, right? Half of pi over 4 is pi over 8. Half of 7 pi over 4 is 7 pi over 8. So I just change all the denominators to 8. So pi over 8, 7 pi over 8, 9 pi over 8, 15 pi over 8. So here are my 9 solutions to this particular problem. Okay. So that's what we got. Okay, so I'm officially done with 4.6 now. And I'm ready to start 4.7 on the schedule. I wasn't supposed to start 4.7 until Wednesday, so I think we're pretty good time-wise. Okay, so 4.7 is on trig identities. Trigonometric identities. So there's a lot of identities that we had in trig. I won't derive most of them. I'll just state them. Perhaps your trig teacher derived those formulas. We're just doing a review of trig in pre-calc, just what you need to get through calculus. Okay, so for most of the formulas, I'll just refer to them, say, here the formulas are, but I won't prove the formulas in general, except for maybe a few. Okay, we're starting trig identities. You're welcome to put all of these on your next cheat sheet. Okay, sine squared theta plus cosine squared theta is equal to 1. We've already tackled that quite a bit. 1 plus tangent squared theta equals secant squared theta. If you start off with this and divide both sides by, let's see, divide both sides by cosine squared, right? Divide both sides by cosine squared theta, you get this. If you divide both sides by sine squared theta, you get this. 1 plus cotangent squared theta equals cosecant squared theta. All right, then we have the sum formulas, SUM. Okay. And I won't prove these, I'll just state them, put them on your cheat sheet. Your trig teacher may have shown you this. Okay. Sine and cosine of a sum, sine and cosine of a difference. I'll combine them into one. Sine of A plus B, or A minus B, sine A cosine B plus minus cosine A sine of B. So this means if you have a plus here, you have a plus here, you have a minus, you have a minus. This is just a more compact way of saying there's two formulas. One formula is sine A plus B, put a plus sign. The other formula is sine A minus B, put a minus sign. So since most of the formulas are the same, right, I just combine it into this, plus minus. Here's the formula for the cosine of a sum or difference, but it's minus plus. The signs, S-I-G-N, actually swap for this identity. So if you have the plus symbol here, the top one, bottom one, bottom one. So cosine of A plus B is cosine A cosine B minus sine A sine B. And cosine of A minus B is cos A cos B plus sine A sine B. Okay, you're welcome to put these on your cheat sheet. Okay, I won't prove these. The book maybe talks about a little bit. You can prove these maybe from your trig book, but we're just doing a rapid review of trig. So some identities for the sine of a sum or difference, cosine of a sum or difference. All right, then we have the double angle formulas. These actually are easy to prove, so I'll spend time to prove this. Sine of 2 theta. You can think of 2 theta as theta plus theta. So sine of theta plus theta and use the top formula. Sine of theta cosine theta plus cosine theta sine theta. Well, that's the same thing. So you end up with 2 sine theta cosine theta. Likewise, for cosine of theta plus theta, I'll use this formula where theta is in both of these. So it's cosine theta, cosine squared, minus sine theta, sine squared theta. So here's a formula for cosine of twice an angle, cosine squared theta minus sine squared theta. Okay, and this is not the only formula there is for double an angle for cosine. There's 2 equivalent forms. Okay, if I change cosine squared theta to 1 minus sine squared theta, that's easy to do because I know sine squared plus cosine squared is 1. So I stick this in here and combine. I also have this formula. Cosine of 2 theta is 1 minus 2 sine squared theta. Likewise, I could write cosine 2 theta as cosine squared minus sine squared. Sine squared is parentheses 1 minus cosine squared theta. If you clean it up, you have 2 cosine squared theta minus 1. Okay, this is the main formula for cosine of double angle, cosine of 2 theta, cosine squared minus sine squared. But this one is also correct. I'll box this out. And this one is also correct. So if you want to put all of these, you may. Cosine 2 theta has 3 forms. This one, or this one, or this one. Okay, so summarizing the double angle formulas, sine of 2 theta, 2 sine theta, cosine theta. Cosine of 2 theta, cosine squared theta minus sine squared theta. Put this on your cheat sheet. And cosine of 2 theta, if you want, you can also put this one and this one. You can always derive them. That's all I do. I just start from here and derive the others. But if you want to put this on your cheat sheet, and this one, this should also say cosine of 2 theta. but if you put them all together, it's obvious. So it's also 1 minus 2 sine squared theta, or 2 cosine squared theta minus 1. Okay. And let me show you in the text. Page 239.
Oh,
Okay.
oh, wait.
So we
Okay.
have these, which are equivalent to what I wrote. I don't really like the way the text writes it with parentheses squared. I mean, I know where they're coming from. That's how you would have to type it on your calculator. But these three are the same as what I got. Let's see, what I put it back over here. Okay. And then these, I don't really like the way they use x1 and x2. Okay. What's wrong with just using A and B? So what are those formulas here? Okay, oh yeah, the text actually goes over a derivation of this cosine of a sum or difference on page 240. You can look at it or not. And then let's see the double angle formulas. Yeah. Page 244, sine of 2x, 2 sine x cosine x, cosine 2x, cosine squared minus sine squared, or 2 cosine squared x minus 1, or 1 minus 2 sine squared x. So again, that's the same as what I did. But this is a little bit more compact, I think. Right here. Okay, yeah. Was there a question? Somebody had a question on something?
Oh, why is it just in they're excluding the tangent double angle formulas? Is that because this section isn't going to be using them, or?
Yeah, the author decided not to have the formulas for tangent, so I'm not going to give it because the book doesn't give it. We can survive without it, and I'll talk about that
Okay.
shortly. But if I feel like I might decide to put it in anyway. But for the tangent, like of 2 theta, you can just go sine of 2 theta divided by cosine 2 theta. You can always go back to that. Okay, but we'll see. But thanks for bringing that up. Okay, now let's see variations of the formula for cosine squared. Okay, so I do have cosine 2 theta is 2 cosine squared theta minus 1. Okay, if I add 1 to both sides and divide 2, I have this formula, one of the so-called half angle formulas. So cosine squared of theta is 1 plus cosine 2 theta over 2. You will see this formula several times in your calculus. Okay, so get used to it. And a warning, by the time you get to calculus, your calculus teacher might make you guys memorize this. So I'm not making you memorize it now. Because of COVID, they said make things easier on the students, so you don't have to memorize it for me, but maybe when you get to calculus, your calculus teacher might say, you guys have to memorize this formula, okay? So just a warning, heads up. Cosine squared theta is 1 plus cosine 2 theta over 2. I'll go ahead and say off to the side, before pandemic, before COVID, I made my students memorize this. So there it is, I even do that. All right, then if I use the other formula for cosine of 2 theta, 1 minus 2 sine squared theta. Cosine 2 theta is 1 minus 2 sine squared theta. Okay. I move the 2 sine squared theta on this side, and I subtract the cosine 2 theta and divide by 2. The equation looks like this. Sine squared of theta is 1 minus cosine 2 theta over 2. Right, so here are 2 half angle formulas. Put this on your cheat sheet. Again, your calculus teacher might make you memorize these. Cosine squared theta, sine squared theta. It's actually easier, in my opinion, if you memorize them both at the same time because they're both almost the same. They both have a 1. They both have a cosine 2 theta. They both have a 2 in the bottom. And the only other thing is this one's a plus, this one's a minus. Okay, the memory trick I was teaching was the sign gets the minus sign. Okay, so if you had to memorize it, which you don't have to do for me, but in case your next teacher says you got to memorize it, for both of these, I would put down the 1. I put the cosine of 2 theta, divided by 2. And then I say sine gets the minus sign. So minus there and a plus there. So that's my corny way of trying to help memorize this formula here. Okay, now, the author on page 246 has this. It actually is equivalent. I would say don't even put it down. You can survive without it. And the formulas you're definitely going to need more often in calculus are these. Okay, so even though these formulas are equivalent to this, I think it's better to work with this because you're going to work with this a lot in calculus. Okay. So they went theta, 2 theta, theta, 2 theta. So to go from here to here, you double the angle. They put x over 2. If you double x over 2, you get x. And if you double x over 2 here, you get x. But this is more in line of what I've talked about. So I would say don't even look at the top version. Let's just go with this. Yeah. So this is what I have. There's nothing wrong with this. It's correct. But what's better for you in the long run in the future is to see this version, because this is the version you'll see in your calc class. Okay, so even though these are mathematically correct, this angle is half of that. This angle is half of that. This is half of that. This is half of that. This is more useful. Okay, so this is what the author has, except for the notation in trig, you're used to putting a 2 there. So this is the version I'm giving you. Okay, so cosine squared theta, 1 plus cosine 2 theta over 2. Sine squared theta, 1 minus cosine 2 theta over 2. Okay.
So I'm assuming this is about to be proof. So if we use so we're not in your class, we're not allowed to use the other forms of the half angle, or in proofs.
Are you not allowed to use the other form? You may use it. Okay. I mean,
Okay.
you're basically using the same formula. It is the same.
Oh yeah, sure.
Okay. You're just saying whatever angle is here, to go from here to here, I double the angle, right? This is half of that. So you either make this not nice and this is nice, or you make this one nice and this one is not nice. Okay. So, I mean, this one has a fraction. At least this one doesn't have a fraction. That's another reason to like this one, in my opinion, is if you got this, okay, I got to deal with fractions. If I use this version, well, I don't have any fractions to worry about, right? Hey, I'm the math teacher, but I don't like fractions any more than you do. If I can avoid fractions, I would avoid fractions, right? So why have fractions when you don't have to? So if you want to use this, it's fine. If you're using this version, you really are using this. And if you're using this, you really are using this. So 6 and 1, half a dozen the other, I guess, is the expression that's sometimes used. Okay. So let me show you the homework, and then I won't go that much farther. So 4.7, 1 to 43 odd. Okay. So page 250. And that. And that. And that. And that. And that should be fine. Okay. There are more formulas called product of sum or sum to product. Okay, they're there. I decided not to include it. They're not used that much in calculus anyway. So since this is pre-calc, meaning getting ready for calc, I decided not to give that to you. But if you want to see where they are, on page 248, we could do problems involving them, but I'm not. So for me, you don't have to worry about any of this stuff. And those are the problems that I'm skipping over here. Okay, so don't think you're getting shortchanged on your education or anything like that. Okay, these kind of problems do not show up that much at all in calc, so that's the reason why I decided not to give it to you. Okay. But all the rest I was going to do is get you started, sort of whet your appetite, do a couple of these kind of problems, and then maybe that's about it. And we'll continue.
Can I ask a quick question about proofs?
Mm-hmm.
I was doing I tried the proof from 4.6 of number 35, and I got the wrong answer, and I think it's because like I canceled first I did math, and then like first I got rid of I got rid of one of the twos because there was a 2 and a 4, right? And then like I split them up and put sine and tangent on opposite sides of the equal operator, then squared it, and then times by I believe it was cosecant squared, and I completely got rid of the sine 2t over, it would be sine 2t over sine 2t. But I went wrong somewhere. It didn't work, and I was wondering where I went wrong.
Yeah, as you can see, I tried to avoid that approach because of what you said, that it's a mess when you end up with the 2t. So that's the reason why I approach it from getting rid of the 2t altogether. So I highly recommend doing it the way that I showed you, as opposed to using identity for that and for that. So yeah, I don't want to take up class time for this. You can talk to me about office hours about that, but
Okay, no.
if you wish. But bottom line, that's why I said don't even do it that way. Do it the method that I showed you. Just, why have a 2t? Just call it theta, work it out in theta, and then when I'm all finished, switch it back to 2t as necessary. Okay. All right, but let me show you how to do a couple of these problems, and then maybe that's about it. So number one, sine of pi over 2 minus 5 pi over 3. So it's a sign of a difference, sign of something minus something. So that's this one. Sine of A cosine B minus cosine A sine B. So sine of pi over 2 cosine 5 pi over 3 minus cosine pi over 2 sine of 5 pi over 3. Pi over 2 is here. Order pair is 0, 1. Where's 5 pi over 3? Well, 2 pi is 6 pi over 3. I back up pi over 3, 60 degrees. Here's 5 pi over 3. Okay. I look for either x or y being halfway across the circle. That looks like y is more than halfway. It seems like x is halfway. So x is a half. 1/2 is automatically always paired with radical 3 over 2. Then get the correct sign, SIGN. I'm in quadrant 4, which means cosine is positive. The SIGN of the SINE is negative. So 1/2 comma negative radical 3 over 2. All right, there we go. Sine of pi over 2, y coordinate, 1. Cosine 5 pi over 3, x coordinate, 1/2. Minus cosine pi over 2, x coordinate is 0. Sine of 5 pi over 3, well, you don't really need it because you're multiplying by 0 anyway, so it doesn't matter what this is, it's going to be 0. But anyway, just to complete it, sine of 5 pi over 3, y coordinate was negative radical 3 over 2, but that's gone. So final answer is just 1/2. So that's that. Okay, 3, cosine of 7 pi over 12. Okay, that's not an angle that I recognize, but I can write it as the sum of two angles that I recognize. Namely, 7 pi over 12 is 4 pi over 12 plus 3 pi over 12. Right? That's 7 pi over 12. And that reduces to pi over 3, something I recognize. And that's pi over 4, something I recognize. Which means I have the cosine of a sum. So cosine of something plus something. Here we are. Cosine of A plus B, cos A, cos B minus sine A, sine B. So it goes cosine of the first, cosine of the second, minus sine of the first, sine of the second. Okay, so I draw myself a pi over 3 60-degree angle. Again, looks like y is more than half, x is a half. Therefore, y is automatically radical 3 over 2. Pi over 4, I know right away both x and y are radical 2 over 2. So we go. Cosine pi over 3, x coordinate is a half. Cosine of 45 degrees, radical 2 over 2. Minus sine of 60 degrees, sine of pi over 3, radical 3 over 2, y coordinate up here. Sine of pi over 4, radical 2 over 2. So the common denominator is 4. 1 times radical 2 is radical 2. Radical 3 times radical 2 is radical 6. So final answer, radical 2 minus radical 6 all over 4. That's it. All right, and that's all I was going to do today, folks. So does anybody have any questions they want to ask me? Let me stop the share so I can check the chat. Otherwise, we're done for the day, folks. Any questions, please? All right, everybody, have a good day, and we'll see you next time. Okay. All right, bye, everybody.
Thank you.
Thank you.